Hello students, welcome to the complex integration session. So in last class I discussed Cauchy's integral formula and and related problems on Cauchy's integral formula. So don't get confused with the Cauchy's integral formula and Cauchy's integral theorem. So okay, just remind this statement of Cauchy's integral formula. So we are using Cauchy's integral formula when f of z is a function, it is an analytic function inside the closed contour C, inside the closed contour C, and so z is equal to a is a point, it is an interior point of C, then integration of f of z by z minus a into dz is equal to 2 pi a into f of a. So ಇದು ಏನು ಹೇಳುತ್ತೆ ಅಂದರೆ ಕೌಚಿಸ್ ಇಂಟೆಗ್ರಲ್ ಫಾರ್ಮುಲಾ ಏನು ಹೇಳುತ್ತೆ ಅಂದರೆ ಒಂದು ಕ್ಲೋಸ್ಡ್ ಕಾಂಟೂರ್ ಇದೆ. ಸೊ ಇದ್ರೊಳಗಡೆ ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ತಗೊಳ್ತೀರಾ ನೀವು 2 ಅಂತ. ಓಕೆ, 2 is an interior point of this region. Now integration of, ಈಗ ಒಂದು ಅನಾಲಿಟಿಕ್ ಫಂಕ್ಷನ್ ಇದೆ f of z ಅಂತ. f of z is an analytic function. So f of z by z minus 2 into dz ಯಾವುದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ ಅಂದರೆ 2 pi I into f of a ಅಂದರೆ 2 ಈಕ್ವಲ್ ಇರುತ್ತೆ. ಓಕೆ, ದಟ್ ಸೇಮ್ ಥಿಂಗ್. ಸೊ ಇದು 3 ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Suppose this is the point 3. So this is f of z by z minus 3 is there here. Okay. So we have to check this point. ಈ ಪಾಯಿಂಟ್ ಏನಿದೆ ಇದನ್ನು ಚೆಕ್ ಮಾಡಬೇಕು. ಇದು ಇಂಟೀರಿಯರ್ ಇದೆಯಾ, ಇದರೊಳಗಡೆ ಇದ್ರೆ so then the integral value is equal to 2 pi I into f of that value. Okay. So Cauchy's integral theorem ಏನು ಹೇಳುತ್ತೆ ಅಂದ್ರೆ, so f of z is analytic function. f of z is analytic function in the closed contour C, then integration of f of z dz over C is equal to 0 ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ಇದೇನಾದ್ರೂ ಇಂಟೀರಿಯರ್ ಪಾಯಿಂಟ್ ಆಗಿರ್ಲಿಲ್ಲ ಅಂದ್ರೆ we consider this whole function is f of z. ಅವಾಗ ಇದ್ರ ವ್ಯಾಲ್ಯೂನ 0 ಅಂತ ಬರೀತೀವಿ ಡೈರೆಕ್ಟ್ಲಿ ಬೈ ಯೂಸಿಂಗ್ Cauchy's integral theorem. we write its values is equal to 0. ಯಾಕೆ ಅಂದ್ರೆ ಅವಾಗ ಅಷ್ಟು ಫಂಕ್ಷನ್ ಅನ್ನ ನಾವು ಜಸ್ಟ್ f of z ಅಂತ ಟ್ರೀಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, it's that same, by using the same concepts I proved, I solved one problem in last class. So in today's session also I would like to continue some more problems on Cauchy's integral formula. Okay, so evaluate. So this integral I is equal to, so let I is equal to, you take this is integration of e to the z by z minus 2 into dz. What is a here? A is 2. And what is f of z? f of z is e to the power of z. So let f of z is equal to, f of z is equal to e power z. And a is equal to, so a is equal to, so it is just like z minus a. In place of a we have 2. A is equal to 2 is the point. So that is the point. So a is equal to 2 is the point. So in first case, so what is the C? Curve C is mod z is equal to 3. So mod z is equal to 3 means it is a circle with center origin radius 3. So if you draw this circle here, like this, just imagine it is a circle. So this is the point 1, 2, 3. Okay, so now this is point 3. So a is equal to 2 is a point inside this region C. So you write a is equal to 2 is the point lying in mod z is equal to 3. So now you can use Cauchy's integral formula here. Therefore by Cauchy's integral formula, we have, so this I is equal to, that integral becomes I is equal to integration of e to the z by z minus 2 into dz can be written as 2 pi I into f of a. What is a here? A is 2, f of 2. So that is, which is equal to 2 pi I into, what is f of z? F of z is e to the power of z. F of 2 is e to the power of 2. 2 pi I into e power 2. So therefore that integral I is equal to 2 pi I into e square. Okay, in second case ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, what is c here? C is mod z is equal to mod z is equal to 1 ಇದೆ ಇಲ್ಲಿ. Mod z is equal to 1. It is a circle with radius 1 and a center origin. If you draw this circle, so maybe like this. So its radius is 1. This is the point 2, 2. This is the point 3. So a is equal to 2 means this is the point a is equal to 2. So this point lies outside this region. ಈ ರೀಜನ್ ಇಂದ ಹೊರಗಡೆ ಇದೆ. ಸೊ ರೀಜನ್ ಇಂದ ಹೊರಗಡೆ ಇದ್ರೆ you use Cauchy's integral theorem and write its answer is directly 0. So mod z is equal to 1. So here a is equal to 1 is the point. A is equal to 1 or 2? 2. A is equal to 2 is the point. Lies outside the region or outside the circle. Mod z is equal to 1. So in this case you use Cauchy's integral theorem. Therefore, by Cauchy's integral theorem, we have I is equal to integration of e to the z by z minus 2 into dz is equal to 0. If this is the point outside the region, write its answer directly as 0. Okay, by using Cauchy's integral theorem. Similarly, take one more example of the same type. Evaluate. So here's you take let I is equal to integration of 1 divided by z into z minus 1 into dz. Z into z minus 1 into dz. Okay. And C is, the curve C is mod z is equal to 3. Mod z is equal to 3. Okay, if you want, you draw this circle. Okay, mark it is x-axis, y-axis, like this. Yes, it is not in our standard form. Our standard form is what? F of z by z minus c. Okay, our format alli z into z minus 1 ide. You try to write this in that same format. So for that, so you resolve into partial fraction. So that is 1. And what is f of z here? F of z andre 1 ide illi. F of z is 1. Okay. So now you take this 1 by z into z minus 1 as a by z plus b by z minus 1. So So resolve into partial fraction. Now after this you write 1 is equal to a into z minus 1 plus bz. So now 1 is equal to, or first to take, put z is equal to 0. What it implies? 1 is equal to a into 0 minus 1 plus 0. So therefore the value of a is equal to minus 1. So the value of a is minus 1. Again you take z is equal to 1, which implies that 1 is equal to 1 minus 1 is 0 plus b. So therefore the value of b is 1. Okay, therefore 1 by z into z minus 1 can be written as 1 by z into z minus 1 can be written as minus 1 divided by z plus 1 divided by b value is 1, so 1 divided by z minus 1. Now integral I can be written as integration over c. This becomes minus 1 by z plus 1 by z minus 1 into dz. Okay, so now this can be written as I is equal to, so minus integration of 1 divided by, or you write it is f of z by z minus 0 into dz plus integration of 1 means that is f of z divided by z minus 1 into dz. Here what is a, or you take a1 is 0, lies inside the circle, mod z is equal to 3. You see that region is, so given region is mod z is equal to 3. It is a circle with center origin, radius 3, 1, 2, 3. So z is equal to 0 means this is the points, first point. So that lies inside the circle. And another point is z minus 1. So that is a is equal to 1. A is equal to 1 is a point lies inside circle. Idu circle ಒಳಗಡೆನೇ ಇದೆ ಅಲ್ವಾ? So now you can use the Cauchy's integral formula. So and a2 is equal to 1 lies inside the circle. Mod z is equal to 3. So in both the cases we can use the Cauchy's integral formula. So therefore I is equal to minus 2 pi I into, in first case it is f of 0 because a is 0 here, plus 2 pi I into, in second case it is 1, so that is f of 1. So therefore it becomes I is equal to minus 2 pi I. What is f of 0? So that function is f of z is 1. f of 0 means then also it is 1. Z is 0 adu 1 because it is a constant function. So f of 0 value is 1 plus 2 pi I into f of 1 value is also 1. So plus 2 pi I minus 2 pi I cancels. So then I is equal to 0 in this case. See one more example of the same type. Z square minus 4 divided by z into z square plus 9 dz, where C is the circle mod z is equal to 1. So that circle is mod z is equal to 1. I just draw that circle now. So it is a circle with center origin radius 1. So okay, now Yeah, so it is a circle with center origin radius is 1, radius of the circle is 1. Okay, so now, so in denominator we have z into z square plus 9. So if you solve this, z is equal to 0, z into z square plus 9 is 0, or if you factorize this one, you can write this z into z square plus 9 can be written as ಇದನ್ನು ಹೇಗೆ ಬರೀಬಹುದು ಅಂದ್ರೆ ಲೀನಿಯರ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಸಲಾಗಿ. So you can write z as z minus 0, and you can write this is z plus 3i into z minus 3i. Or if you solve these points, or you can write it as z minus 0 into z minus of minus 3i, you can write, and this is z minus 3i. These are the points. So z is equal to 0, z is equal to minus 3i, z is equal to plus 3i, or you can take these points. So these points, in these points, z is equal to 0, 0 lies inside the circle. This is the point origin. Okay, so lies inside the circle. Mod z is equal to 1. But if you take this point, z is equal to minus 3i, or you can write this point is 0 comma minus 3. So 0 comma minus 3, and this is the point 0 comma 3, and the points zero comma minus 3 and 0 comma plus 3 lies outside the circle. So here the possibility is you can write this is z into z plus 3i into z minus 3i, and resolve into partial fraction. After that, we have to use the Cauchy's integral formula for this z factor. Is z plus 3i and for z minus 3i, we have to use the Cauchy's integral theorem. We have to do directly 0 ಬರುತ್ತೆ. So instead of doing all those steps, we can easily avoid that steps. So that is, you take this integral I as I is equal to integration of ಅದನ್ನು ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡೋಣ, you write this is z square minus 4 divided by z square plus 9. ಈಗ ಬರೀಬಹುದು, ತೊಂದರೆ ಇಲ್ಲ. This divided by z, or you can write it as z minus 0 into dz. So here f of z is, that is f of z is, you take this whole function is f of z. F of z is z square minus 4 divided by z square plus 9, and a is a point 0, so and a is equal to 0 lies inside the circle, inside the circle. Mod z is equal to 1. Okay, so this is the point, interior points. Now you can easily use the Cauchy's integral formula. Cauchy's integral formula ಬರೋದು ಯೂಸ್ ಮಾಡಿದ್ರೆ ಹೇಗೆ ಬರೀಬಹುದು ಇದನ್ನ ಅಂದ್ರೆ, therefore by Cauchy's integral formula, we have I is equal to 2 pi I into f of 0. What is f of 0? You put z is equal to 0 here. So that is 2 pi I into f of 0 is 0 minus 4 by 0 plus 9. So that is equal to minus 8 pi I by 9. So like this. So take one more example of the same type. So here that circle is with radius 3. Circle is with radius 3. Okay, so you take these points is 1, 2, 3 like that. This is the origin 1, 2, 3. Yes, you take this integral is I is equal to integration over c sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 into dz. As here f of z is, you can take that numerator function is f of z. So f of z is sin pi z square plus cos pi z square. So and the points z is equal to a, so that is the a is the point 1 and this is 2, both lies inside the circle. This circle ಒಳಗಡೆನೆ ಬರ್ತದೆ ಎರಡೂನು. Okay, so now you take resolve this into partial fraction, so that a is equal to or z is equal to, so you can take this point is 1 0 and z is equal to, this is the point 2 0, lies inside the circle, lies inside the circle. Mod z is equal to 3, mod z is equal to 3. Okay, so you take this and resolve this into partial fraction. ಹೀಗೆ ಇಟ್ಕೊಳ್ಳೋ ಆಗಿಲ್ಲ, ನಮ್ಮ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ಗೆ ರಿಡ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಕು. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ ಕೌಚಿಸ್ ಇಂಟೆಗ್ರಲ್ ಫಾರ್ಮುಲಾದ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ ಏನು, ಎಫ್ ಆಫ್ ಝೆಡ್ ಬೈ ಝೆಡ್ ಮೈನಸ್ ಎ, ಆ ಫಾರ್ಮೆಟಲ್ಲಿ ಇರಬೇಕು. ಸೊ ರಿಸಾಲ್ವ್ ಇಂಟು ಪಾರ್ಷಿಯಲ್ ಫ್ರಾಕ್ಷನ್ 1 by z minus 1 into z minus 2 can be written as a by z minus 1 plus b by z minus 2. Okay, its simplification gives that 1 is equal to a into z minus 2 plus b into z minus 1. Put z is 1 here first. So then which implies that 1 is equal to a into 1 minus 2 plus 0. So therefore the value of a is minus 1. And again put z is equal to 2, which implies that 1 is equal to, so this becomes 0 plus b into 2 minus 1. So then b value is 1. A is minus 1, b is 2. So then we have is 1 by z minus 1 into z minus 2 can be written as minus 1 by z minus 1 plus 1 by z minus 2. So now I can be written as I is equal to integration of integration over c, so minus f of z by z minus 1 into dz plus integration of plus f of z by z minus 2 into dz. Okay, so now z is equal to 1 and z is equal to 2 are the points lies inside the circle. So therefore by using Cauchy's integral formula, therefore by using Cauchy's integral formula, we get I is equal to minus 2 pi I into f of 1, because in this case, in first case a value is 1, plus 2 pi I into f of 2. So that is I is equal to, so minus 2 pi I into what is f of 1. So what is f of z here? So that is sin pi z square plus cos pi z square. So f of 1 means sin pi 1 square plus cos pi 1 square plus 2 pi I into this is sin pi 2 square plus cos pi 2 square. As all of you know that sin pi value is 0, this becomes 0. Cos pi is minus 1, so in first case, therefore I is equal to minus 2 pi I into 0 cos pi is minus 1 plus 2 pi I into sin 4 pi is also 0. Cos 4 pi is 1, so it is 0 plus 1. So that is 2 pi I plus 2 pi I, which is equal to 4 pi I is the required value of the integral. Okay, so it is very important problem. You should concentrate on this one. So next, in possible, try to solve this cos pi z by z square minus 1. Okay, around a rectangle here, that region is not a circle. Okay, that region may be any closed contour. Here that given contour is a rectangle 2 plus or minus I and minus 2 plus or minus I. Take all those 4 points and draw the line segments, you get a rectangle. Okay, in this points you check the z square minus 1. You can write that is z minus 1 into z plus 1. Check whether that values of a's or lies inside the rectangle or outside the rectangle. Based on that, you decide you have to use Cauchy's integral formula or Cauchy's integral theorem. Okay, so in the coming classes I will solve some more problems. Thank you.